This is a superb structure built by the United States in the 19th century, the Washington Monument. It's made of marble and pumice stone shipped from all over the United States. There is not a single letter on the monument. It surpasses all the cathedrals of Europe and the pyramids of Egypt. It stands proudly in the center of the National Mall in Washington, D.C. But shockingly, just a third of the way through the monument's construction, it had sunk a meter into the ground and was tilting. In order to find out why, engineers dug a tunnel directly to the foundation. It turns out that the soil in the area where the monument is located is very soft and glutinous, basically clay and sand. This makes the foundation extremely unstable. If the original design had been followed, the world would have seen a new leaning tower, or worse, it could have collapsed. American engineer Casey found a way to do it by digging up the foundations and removing the excess soil on one side of the monument to bring the monument back to vertical. Then workers dug a series of tunnels around the perimeter of the foundation without destroying the existing structure and then filled them with concrete. Fortunately, the massive tower base eventually connected the old tower to the new foundation. It's rock solid and stands 169.045 meters tall. It became the tallest stone building in the world. In 1889, a French engineer named Gustave Eiffel submitted a radical proposal. He thought steel was the perfect material for the tower. He directly attached 18,000 steel parts with 2.5 million rivets. The base of the tower was assembled as 4 discrete pillars, with tall arches connecting them. The central tower becomes a steel skeleton. The upper part of the tower is formed into a roof that reaches more than 300 meters into the sky. Amazingly, the Eiffel Tower, weighing 7,000 tons, was assembled by only 130 men. First, the Eiffel Tower's frame was assembled on the ground. Then, a large crane was used to lift it high into the air for assembly. And to make sure that each floor was perfectly level, they installed hydraulic jacks underneath each support and constantly adjusted them. And so, step by step, as the crane rose, the Eiffel Tower climbed higher and higher. Interestingly, just after the tower was finished, the crane's tracks were transformed into a working elevator. The final Eiffel Tower was about 300.65 meters high and became a landmark in Paris, France, and remained the world's tallest building for 45 years. In 1968, Canada wanted to build a national television tower. Engineers wanted to build it out of reinforced concrete. First, a 3-story concrete mold was assembled. Workers would pour a steady stream of concrete from the top into the molds below. As the concrete hardened, the power of hydraulic jacks will be used to lift it upward step by step. Reinforcing bars will then be placed through the concrete shafts to the bottom of the tower. Then the hydraulic jacks are used to tighten the rebar so that it is securely fastened to the foundation. Thousands of kilometers of rebar were used in the National TV Tower to withstand earthquakes of up to 8.5 magnitude. The final Canadian National TV Tower is about 553.3 meters tall, the tallest freestanding structure in the world, and was named one of the 7 wonders of the world. Normally, when strong winds blow through a conventional tower, the vortex created would pull the tower to one side and cause it to collapse. But China's Canton Tower has done it again with its irregular, twisted shape. Plus, the open mesh structure of the tower's exterior makes it possible to disrupt the vortex formation, and thus reduce the amplitude of the swing. That's because clever engineers divided the tower's foundation into 2 parts. First, the massive concrete base was built directly into the bedrock, which serves as a strong foundation support to further secure the tower's exterior steel structure. Workers dug a large number of shafts around the core foundation. Each shaft is 20 to 40 meters deep and 4 to 5 meters thick, and were poured with concrete during the excavation process to prevent wet soil from falling into the shafts. Finally, A ring of concrete beams was formed at the top of the shafts to connect the shaft to the massive steel pillars. And at the center of the tower is an inner core of reinforced steel and concrete to house the elevators and staircases. The tower is divided into 5 functional sections, A through E, including equipment floors and sightseeing corridors. The exterior of the tower consists of 24 concrete tilt columns. The entire tower is characterized by 2 elliptical rotations at the top and bottom, and shrinking and thinning at the waist. In order to further strengthen the waist, the engineers built 46 sets of steel tube beams on the outside of the tower to form a strong, tapering grid structure and tightened at the slimmest waist. At the slimmest waist, while the lattice work is loosened at the top and bottom. Saves material and makes the tower lighter and more upright. The final tower has a total length of 600 meters. Known as the Little Barbarian Waist, it has become the #1 tower in China.